Alright, today we're going to be talking more about quadratic functions. Now, yesterday we talked about a little bit of the quadratic function and the shape that it makes. But a quadratic function is called a parabola. The shape that it makes is called a parabola. Remember, it's a smiley face or a frowny face. Makes it U or upside down U. Every parabola has a maximum or minimum at the vertex. So each maximum or each parabola either has a high point or a low point. The high point is called the maximum. The low point is called the minimum. Minimum will be on the smiley face or the U-shaped. The maximum will always will be the vertex on the upside down U or the frowny face. Okay, so that's more about the quadratic function. We're talking about what they mean in terms of real life type problems that you're going to see. Okay. Now, when we get into graphing these on the calculator, you're going to see the shape that it makes on that x and y axis. So I have my y axis here, and I have my x axis here, just like a coordinate plane that I normally have. And then I decided I just threw a quadratic graph on there, a parabola. There's a frowny face, upside down U of a quadratic function. Okay. Now, when I'm talking about in a real life, and we talked a little bit about this yesterday, this would model maybe a roller coaster going up and then going back down. It actually would follow that path, just like a ball. If I threw it up in the air, it would eventually come back down. It'd start from a height, it would go up and then come back down. Now, the two axes, they measure different things when we're talking about real life situations. The x-axis, which is this thing right here, the horizontal axis, normally is going to measure time or distance. So if I was throwing a ball in the air and I started from here and it hits the ground here, I want to see how long is that ball, while the ball is traveling in air, how long is it taking for that ball to come all the way back down over here? Okay? So this x-axis would measure time. It may measure distance. Say it's the roller coaster, and it wants to see how far it goes up and then comes back down. What's the distance from here to here? Even though it travels this distance this way, the distance from point A to point B is going to be shorter, and they want to see how far that distance is based on your quadratic function. Okay? So if the x-axis is measuring time or distance, the y-axis will always measure height in a real-life situation. Okay? So if I was throwing that ball again, if I threw it up, it's going to hit a certain point, and that height is what I want to measure. Okay? That maximum point that we talked about yesterday, the max, is what I have labeled here, is the vertex. That's the highest point. I want to see how high did that ball or rock or whatever I was throwing or whatever was being shot up in the air, how high did that get? Okay, so that's what a real life situation may look like when graphed on a coordinate plane. So you have your x and you have your y axis. Those two things, you're going to have to remember what they mean. Okay, and just trying to help you figure out and go ahead and get your mind ready of thinking about word problems. Normally, these are what the two things are going to be asking you about. Okay, we'll see that at the very end in our example. Okay, to find the x-coordinate of the vertex of any parabola, we will use the following formula. So this is just for the x-coordinate. If I went back, or if I looked at this graph right here, and we talked about the x and the y-axis, the vertex is going to be a point, a coordinate, an ordered pair. All those things mean the same thing. So we're going to look at the formula to find just the x number. If we had an ordered pair x, y, we're looking at this formula for just the x number. Okay, just to find the x-coordinate is going to be the opposite of b over 2a. And if I was looking at my quadratic function, yesterday you wrote it down, but here it is again, ax squared plus bx plus c. So you would take the opposite of b, regardless of what it is. If it's positive, it would become negative. If it was negative, it would now become positive. And then you divide it by 2 times a. So whatever a is, you just multiply it by 2. That's going to get your x-coordinate for this maximum or minimum point, depending on the graph. Okay? So to find the max or minimum x-coordinate, I would use this formula. And then I would take that x that I got, that x value, and plug it back into my x's here to help me find the y spot. So I would have an x comma y for my max or for my min. And once I find the x, I plug it back into my equation, because remember this is now an equation, and I would get my y value. So I would be able to write a ordered pair for that maximum or for that minimum spot, depending on what the graph is. Okay, so we'll practice more with that. That's just the formula to find the x-coordinate of the vertex. And if I notice, before I move on, that parabola, a u and the upside down u, they normally are going to be, they always will be symmetrical. Okay, so the line that I have drawn here is mainly to show that this line is separating my parabola into two halves, and those two halves are symmetrical. It's handwritten, so it doesn't look symmetrical, but on a graphing calculator, your parabolas will be symmetrical. So this line that goes through that vertex is called the axis of symmetry. So when you find that x value, you're finding the x on this x-axis, the line of symmetry. Okay, so I could draw a line right through that vertex, and it's going to hit the same. It's going to go straight down, hitting the spot on the x-axis, and that is the line of the axis of symmetry for your parabola. That's why I have that dotted line there. You may have a question asked about the axis of symmetry, and it's just simply being able to determine what the x-coordinate is from your quadratic equation. All right. So here, let's practice. It says find the coordinate of the vertex. So we're going to do the whole thing, not just the axis of symmetry. We're going to find the coordinate. Now, if I look at this, I have the f of x, not y, but f of x and y, we know are the same thing. This is the function of x equal to x squared plus 6x minus 15. I want to find just the x-coordinate first. I'm going to use that formula. It is the opposite of b over 2a. So b in my quadratic equation here is 6. The opposite of 6 is negative 6. Then I look at my a. My a is just a 1. There's no number out in front, so it's understood to be 1. So I do 2 times 1. That becomes negative 6 over 2. Negative 6 divided by 2 is simplified to negative 3. That is the x-coordinate for my vertex. I take that negative 3, and you can see I plugged it into the equation I started with. So now instead of x squared, I have negative 3 squared. Plus 6 times, not x, negative 3. It's now negative 3, and then minus 15. I do the math. Negative 3 squared is 9. 6 times negative 3 is negative 18, and then I have the minus 15 at the end. We got 9 minus 33, and that becomes negative 24. So I have my vertex at negative 3, negative 24. Now I have minimum here. How do I know it's a minimum if I don't even have the shape of the u or upside down u? The way you can determine, and this is really easy to determine, the way I determine if it's a min or max without looking at the picture is looking at the coefficient, the leading coefficient. If the leading coefficient is positive, which it was here, the leading coefficient is positive, we're going to have a minimum. If the leading coefficient is negative, it's going to be a maximum. It's going to form an upside down u. Okay, so the shape of this graph, because it's a minimum, is just going to be a normal u. Because I have a minimum spot. If I thought about the notes I took yesterday, you drew a picture of a u and upside down u, and you labeled the upside or the regular u, the smiley face, with the minimum point. Okay, so this minimum point is when there's a leading coefficient that is positive. Now if it was negative, it would be the other way, but because it's positive, I have a minimum at negative 3, negative 24. That is the vertex of that minimum spot on my parabola. Okay, so that's how you use the formula to find the x, and then plug it in to find the y, and find your vertex. Alright, so that is finding the vertex. Now, this, let me erase this. You're going to take time right now to copy this down, and then you're going to answer. What it's asking you to do, to find, it's talking about an Olympic diver is competing for a medal. His height in feet above the water can be modeled by the function f of x, this is 3x, negative 3x squared, plus 6x plus 24, where x is the time. So there, I just told you x measures time. X is the time in seconds after he begins the dive. This is going back to yesterday's notes. I'm letting you see a word problem. We're kind of easing you into it. It's going to be using yesterday's notes to find how long it takes the diver to reach the water. So now you've seen what it means for the quadratic function on a graph, and maybe you can have a visual of the parabola it's going to make without using a calculator. You're going to find how long it takes the diver to reach the water. If x is the time in seconds, all you're going to need to do is solve for x. Okay? So you're going to solve for x here, just like we did earlier with just the simple basic application problems where you did them on the task cards. Now you're going to apply this to a word problem. Find how long it takes the diver to reach the water. So you're going to solve for x. Tell me in seconds how long it took that diver to reach the water. All right? I also want you to just draw a picture so you can have a visual of what shape this is. If you look at your leading coefficient, you tell me, is it going to be a max or is it going to be a min? I need to know that. Draw a picture of your graph and tell me if it's a max or min. So there's two things I need. Three things, really. You need a picture of the shape, either a U or upside down U. Tell me if it's a max or min. And then I need x equal to some time in seconds. You tell me what the time in seconds. All right? So think about what your answers are going to be, and then you box all that stuff up for me so I know what your answer is.